Hi students, good afternoon. This is M. Srinivasan working as assistant professor in ECE department and Nanda Engineering College, Erode. And today we are going to see the laboratory experiments for our IT students. And our subject code is 17ECP02 and subject title is Electronics Laboratory. So in our laboratory experiments, totally it consists of 10 experiments. So at first we are going to see about the characteristics of PN junction diode. For this experiment, first we need to know what is the circuit and what are all the components needed to complete the circuit. Okay, let's go to the circuit diagram. So as you can see in the figure, on the left side we can start from the left side of the circuit. On the left side we need the 0 to 30 volt variable power supply. Then followed by we need 1 kilo ohm of resistor, and this resistor is connected seriously with the 0 to 200 milliampere ammeter. Okay, and we have a 1N4000 diode which is connected parallelly with the power supply. Okay, so again we have a voltmeter on the right side of the circuit which is connected parallelly with the diode as well as voltage source. Okay, so let's construct the circuit. So due to this pandemic situation, I can't simulate the circuit in hardware. Due to this pandemic situation, I can't explain the circuit with the hardware. Instead of hardware, I am going to use the electronic simulator software called Proteus 8 Professional. So already I have installed that software in my PC. So if you want the installation procedure or installation process, I put a separate video as per your requirement. Okay, let's go to the experiment. Just press the start menu and you can see the Proteus 8 Professional, okay, icon. So just click the icon, it will pop up the Proteus design suite version 8.0 and lead to the current window. Okay, so here you have to click ISIS icon, which is called schematic capture. After pressing this icon, it will bring up to the workspace. Okay, so in the workspace you can see a blue color border on the workspace. So that means inside this border only we have to place all the electronic components to form a circuit. Okay, on the left hand side we have P and L icons, which is used to pick the devices from the software, and L stands for library of devices. So if you have a unknown components in your circuit, that means it is not available in the software, you can add its behavior and you can form a new component. Okay, that is why we have a library. Okay, so for this experiment we need 4 components. First one is voltage source, 1 kilo ohm of resistor, 1N4001, and finally we need the ammeter and voltmeter. Let's check it one by one. So first what we have to do means we have to do V sign, which is called voltage source. It will be pop up in the result space. So just double click it, it will be added in the device list. Okay, then reset the keywords and again you have to enter 1N4001. Okay, so this will give 4 different results. Among these 4 you have to choose the first option. Okay, just double click it, and finally you have to need 1 kilo ohm resistor, or you can put it as 1000 okay. So in that you have to click the resistor tab. So here you have to see variety of 1 kilo ohm is there, so but you have to choose 1/8 watts, okay, or 1/4 watts. Okay, 1 kilo ohm 1/4 watts. Okay, just double click this item and it will be added in the circuit. Okay, in the device list. So now look at the diagram. So again we need 2 more things. First one is ammeter and the next one is voltmeter. Okay, so first what we have to do means just close this window and go to this icon and click here, and in the bottom side you can see DC voltmeter. Okay, just double click, just click and place it. okay, and a DC ammeter. Okay, just place these two things in the circuit itself. Now go to this icon component mode, click here, and it will shows the components list. Okay, and one more thing is we need just click the P icon and type it as pot HG. Okay, or just put it as pot. So in that you have to choose the pot HG, okay, and add it. So this pot and the voltage source, both combining these both will give the variable power source. Because it is a simulator, we can't have a variable power supply with this. Okay, just click here and drag it to the workspace and place wherever you wish by clicking the click it once again. Okay, next take the pot HG and place it parallel with the source. Okay, connect both terminal. Okay, when you are placing the pen icon to the source, it will show the red color point. That means it is ready to accept the connection. Okay, just click here and place it over here. Now it is over. So here you have to take the output. So this will be the positive supply. So before that, I am just going to drag this icon. I am going to choose the 1 kilo ohm resistor to the circuit. Okay, so now click this point and connect with this 1 kilo ohm resistor. Next we have to connect the ammeter with this circuit. Just connect the positive terminal to the positive and negative terminal. Before that you have to connect the diode. So just click the diode and place it in the workspace. Okay, by pressing the negative sign, you can rotate the item. Okay, equipment. Now connect the anode to the negative terminal and cater to the supplies negative. Okay, finally you have to connect the, I am just dragging this voltmeter here. Just click the positive terminal, click this point and connect with the positive terminal of voltmeter, and negative terminal of voltmeter should connect it to the another point of voltage source. Okay, now one more thing is we have to do, that is right click and choose the place tab. There you have a terminal. So in the terminal you have to choose the ground. Okay, just place it in anywhere of bottom of this circuit and connect this ground terminal to the bottom of this above circuit. Okay, now the circuit is over. It is not that much visible, so we are going to zoom the entire circuit. Okay, just press the icon and click and drag it. So our circuit is ready. Now what we are going to do is we are going to verify this VA characteristics. First we are going to take the forward region or forward bias mode. Okay, so I already told that for a forward bias operation, after 0.7 voltage the device starts to conduct. That means there will be the current flow in the circuit. So that can be checked with this circuit. Okay, so to check the forward bias operation, that means first quadrant operation, I am going to keep the diode in forward bias condition. That means I am going to apply the positive supply to the anode of diode and negative supply to the cathode of diode, right? So this is what I have connected the circuit. Now one more thing, in the simulated concept we have to give the amount of input voltage. So by double clicking this V sign item, so this will pop up a edit component window. Okay, here in the amplitude menu you have to give 50 volt and the frequency is 50 hertz, and if you want to change the equipment's name or device name, just press the AC supply. Okay, right. Now what we have to do means, by pressing this play button you can start simulate this entire circuit. Okay, so as you can see the device gives 0 voltage. By pressing this Actually, I have to use the DC supply. I wrongly connected this AC to the supply to the circuit. That is why it is not shown in the voltmeter. Okay, just replace this circuit and click the sign generator mode, and you can choose the DC. So just place it here in the circuit workspace and click this power source to the resistance. Okay, now double click on this DC power source and change the value as 50 volt. Okay, now it is over and you can start the circuit simulation. So now we have applied only 0.75 voltage. Okay, just reduce the value. So for 0.7 voltage, the device starts to show the current value. When we are reducing the voltage or increasing the voltage, so I'm just going to increase the value. So the current value is voltage value is 0.75. There is no changes in the current. Again, I am going to increase the value of voltage, input voltage. To measure the input applied voltage, I am just going to place a voltmeter in the input side itself. Just connect it here. Just connect it here. Okay. So now look at the graph. So after 0.7 voltage, the forward voltage will be constant and the current value start to increases. Okay. So let's check the behavior. Go to the Proteus software, and now I am going to simulate the circuit. Okay. So now the input applied voltage is 0 voltage. The input voltage is 0. At the same time, output voltage is also 0. Current value is 0. I am just going to increase the input voltage. Now it is 0.5. 0.48 voltage is available in the output side, but there is no current flow. Okay. Again, I am increasing the value, input value. Okay. 0.99. So this time also it is 0.58. There is no current flow. When the output is crosses 0.7 voltage, there will be the current flow in the through the diode. Okay. Now 0.61, there is no current flow. Again, I am just increasing. Now it is 0.62, there is no current flow. Again 0.64. And keep on increasing the input value. When it crosses 0.7, the ampere rating start to increases. Again, I am increasing the current value, that means voltage value. So but whatever I am increasing the input value, it remains 0.7, but the current value is increasing from 0 to somewhat level. Okay. So this is how the PN junction diode will behave. It is about forward bias condition. Next we are moving on to reverse bias operation. For that we need to connect the diode in the anti-parallel connection. Okay. Just remove the connection. Just connect the anode to negative and cathode to positive. Okay. Now the circuit is working in reverse bias condition. Then I am going to simulate. So after 27 volt itself, there is no current flow. Again, I am just going to increase the input current. Now it is 30, there is no current flow. Again it is 40, there is no current flow. Again it is 50, there is no current flow. Now look at the diagram. In reverse bias condition, the breakdown will occur, but this breakdown is called avalanche breakdown. So once the avalanche breakdown occurs in a reverse bias mode, the entire circuit will be damaged. That means device will be damaged. So after this avalanche breakdown occurs in a PN junction diode, the PN junction never back settle down. Okay, the junction will be busted out. Okay students, this video definitely helpful to you all. So just try this circuit with your laptops or PC. I am just floating this Proteus circuit in the description box itself. Just go through that and simulate by yourself. If you have any doubts, you can ask me in the comment box below. Okay. So the upcoming videos are quoted in our channel itself. Just subscribe our channel, and I'll float the experiments one by one. Okay. Okay, students. Thanks for watching. Thank you.